We're really excited to have a few, final, really interesting conversations and talks. I'm Kate Timmerman. I'm CEO of the Chicago Quantum Exchange, and we're going to start off. I believe we are deviating from the printed program, but we wanted to carve out some time for a really special talk here. We're going to have a conversation with Katie. I told you I was going to mess up your name. Pizzolato, who's Vice President of Algorithms and Scientific Partnerships at IBM, and Preeti Chalsani, who, as we have met before already, is Chief Quantum Officer at Intersect, Illinois, and really representing all of the state of Illinois. And they're going to kind of have a carve out and a brief conversation about, developing algorithms, developing in mind and with end users and use cases. So at this point, I'm going to turn it over to Preeti.
Thanks, Kate. And thank you all for sticking it out until the end. But I promise you there's lots of great stuff coming even after our panel. So I actually have a lot of questions for Katie. I love her title, Algorithms and Partnerships, because I've got lots of questions about algorithms and partnerships together.
You guys should count how many times we say those two words throughout the talk.
It's towards the end of 2 days of lots of interesting sessions. So we're definitely
punchy.
So, Katie, just to get started, I think most of us are very familiar with IBM's work in quantum computing, especially all the, your leadership in hardware development. I think we know a little bit less about how IBM's working on algorithms. Is it in partnership with the hardware team? Is it separately? How do you think about algorithms within IBM? And how does that help advance quantum computing in general?
Yeah, thanks for having me. Thanks, like she said, for everyone sticking in. So IBM, I would say the strengths and exciting parts about IBM is that we all are, most of us, we have a global footprint, but we work very closely with the hardware team and the experimental team. And I would say, upper level, we know that we have algorithms. We have algorithms that we have proven algorithms. Algorithms that we can't do on quantum computers today. And then we have a lot of heuristics. And I think what we think a lot about is how do we meet those heuristics with rigorous experimentation? We've got to do a lot of classical things to get some intuition about the problem. We need to meet that with where our devices. We work closely with our experimental team to get the most out of the devices. We look at how do we reduce the circuit depth? How do we use error suppression, error mitigation methods? How do we have better compilers to work on these systems as well? So I think that big picture, we know that there's a lot of algorithms out there, right? If you look at the algorithm zoo, but they haven't really been met with a problem as well. So we need better algorithms, and we need to map those algorithms to problems to bring everything to life that we're all here and all very interested in. I think a lot of interesting things coming out of the algorithm space these days is looking at how classical and quantum computers really partner to kind of, again, extend what we can do with the devices that we have. There's so much excitement in the space, but this is a place where we very much need to continue to focus. I think we've, between all of the industry players and all of the private and public sectors, we've kind of got a lock on hardware. Now we really need to start to think about how to get a lock on how we're going to use that and really bring the hardware to life, the kind of the why of the hardware.
Right. So speaking of the why, so how are you working towards actual applications, and how are you working with end users? How should the community make sure that we're sort of tightly working across the spectrum from hardware development to end users?
Yeah, and I think there's a lot of good examples we've heard all throughout the last couple of days, and obviously the ecosystem, especially the one here that is really tying in academia, industry, and government together. I think there's a really positive, and I hate to even say the word tension, but if I can say like positive tension, and if you partner academia and industry together, because you've got the demands and like the impatience sometimes of industry saying like, what am I going to do and when am I going to do it? And you've got the rigor of the scientific community saying, here's how we're really going to look at this. So I think there's lots of great partnerships in this model between industry and academia and that end user. A lot of the people thinking about algorithms are not necessarily subject matter experts that are thinking about how are we going to use those algorithms to something. So I think that partnership is really important, and we've seen that through our own industry partnerships, as well as our own academic and other kind of collaborations where you put those different skills that are looking at the problem from a different lens, the quantum native lens, the subject matter expert lens, whether it's a chemist or computational chemist or something like that, and we've seen some really great results.
Are there specific areas in which you think we're doing really well? Specific industry sectors maybe, or where?
Yeah, I think I would say that where I think a lot of industries are doing really well are the ones that are treating this technology as a technology that they know is going to impact their business. Mm-hmm. I heard this on the panel a couple different ways today, or like a couple different times today, that quantum sometimes gets in this like, oh my gosh, it's so incredibly different. You can't understand it even if you try. That it's like a really inapproachable technology, and it's not. I think a lot of people are approaching it, not just really physics-based people, but a lot of other different skills are coming together. And I think the industries that are thinking about this is a technology that I need to understand how to bring into my organization. I need to approach it like I would anything else, and I need to start small. Right? You don't need a large group to start examining this technology. And one of the things that I say a lot is, if you were graduating within this domain, and I know physics, as we all know, has a very broad spectrum of activity within it. If you're graduating in this domain earlier than about 2015 or 16, and you didn't want to pursue an academic stance, you likely ended up somewhere in industry or startup community that wasn't specifically quantum. Almost all industries have somebody in their organization that knows about this technology in some way, but also has been embedded in their own organization that knows their own problems. So I think the industry, the people in industry, they're looking at this as, okay, this is another technology I need to know how to consume, and they're looking internally first for their own champions, and then using all of the resources that we have within the broad community to start to tackle those have been very successful.
So sort of bringing together the domain experts in the industry or the company and the technical experts from whether it's academia or industry. Industry, anybody who's going to make an investment in a technology, especially something like quantum that is in its earlier days, needs to have a motivating factor within their organization. They need to know what they would want to solve if they could, or what the problems they have facing them that they do have computational challenges with, and they need to start to think about where quantum might be viable, where it might not be viable, and where to make that investment for value within their own organization. So I think and there's so many companies that are involved in really starting out their quantum journey, but I would say if you looked across that broad spectrum, they all have that thing in common. The successful organizations have had that thing in common. They're looking internally at people that have maybe a more quantum native lens, but they're partnering that with SMEs in the organization, and they're thinking about what is that thing that they want to go after, like what's their focus, what's their drive to do this? Where can quantum actually provide a solution?
Yeah, and starting
to improve
to
their solution.
Yeah, and we heard on the government panel earlier, there's a lot of misinformation out there. There's a lot of maybe misinformation is the wrong thing, but it has become a complicated topic. And I think the more you within your organization find someone who is like your own inner source of truth, and can start to tell the stakeholders and tell the people making the decisions, like what's really going on, what is the state of the art, right? What is the lay of the land? What are the use cases that seem viable? When do we think those things might be viable, and what do we need to do to get them to be viable? has been successful. And we'll put viable on the list of words for you guys to count how often I use it.
So I think what you're trying to say, and maybe the IBM quantum team will not like me for saying this, is don't think about quantum as a thing by itself. Like it's really part of, like it fits into this toolbox of whether it's AI or other forms of computing if we're talking about quantum computing.
Yeah, and I think what's really important, and you've heard IBM talk a lot about utility, and we use that word very specifically. It's a tool, and we need to use it, and we need to figure out what it's going to do, and it's going to likely do things for everything that we know and everything that we have, it's likely going to do things very different for very specific problems, and we need to find those problems, and we need to find algorithms that show value to those problems, and we need to map those problems to these devices through that empirical study to really get the value out of them. So I think we need to approach it, of course, as something, what's the word I'm going to use here? Something exciting sounds a little too less, but not different. I think different is where we get off track. Like,
right.
It is a new technology that is going to be valuable and have an enormous impact.
Yep.
And we need to treat it as a new technology, just like we have other technologies where we get something new and we use it and we try it and we understand what it's going to do. And when it doesn't do what we want it to do, we look toward what's next and what we need to change to do that. And I think sometimes that's what's missing in the quantum discussion. The idea of really using the tool to derive its value.
Is it different, like when you're talking to the end users? Do you see them thinking about it in a different way?
Well, I think now it's like a therapy session up here.
Yeah.
But I think
Sure.
Sure. I mean, we're there, right, in that point of the day. I think the technology, and I would love to hear other people's opinion on this as well. But it kind of got pigeonholed into the use cases early, right? It was going to do these kind of couple things, and I think because of that, we took a lot of the innovation and creativity and the kind of journey out of it.
Yeah.
And I also think that we've become really accustomed to technology that when it shows up, it's like, oh, here, use the product, this is what it's going to do. And I think this is different in that way. Like we are pioneers. Everyone in this room, everyone who's talking about this, we are pioneers in this journey. As a part of being a pioneer, we need to be ready for a twisty, non-straight line. And I think sometimes when we jump straight to the end user and we don't think about the discovery and the research that needs to be done in the middle with the end user in mind, and that draw from, like we were saying, industry or demand, we miss that part in the middle. So I think sometimes when you jump to the end state, it's like, what do I do with it today? And it's like, well, that's part of what we need to work together to do. We've got to map these algorithms. We need to make better devices. There's a lot of other things we need to do, but we've got to have that pull from the user and from the use case to drive where the rest of that research is going.
So be strategic about it.
Yes. Yes.
So I see people in the audience from like bigger companies to some from smaller companies. And so I guess there's a question there, like how should you start exploring and eventually adopting quantum computing? And it also applies to communications or sensing technologies. Like how do you get started?
Yeah, I think, well, and what I hope everybody recognizes is that the barrier to entry is quite a bit smaller, I think, than people think, right? We've got a ton of resources out there from educate. I mean, IBM obviously has a lot of education. There's education within the community. There's a lot of different modalities and systems out there. We've got free hardware access. There's other hardware access that we heard other industry players and startups and others talking about using. So there really is nothing preventing you from starting tomorrow, I think, on your journey. I think the part is what we said to get really started is to identify the champion. Like you need to identify like a small cohort of people that are really interested in this pursuit. And what I find as well, whether you're talking to academic groups that are thinking about workforce development, or you're talking to industry players that are thinking about people within their organization that are looking for growth and looking for development, like this is a great place to get people interested in what the next technology is going to be and how is that going to impact my organization, how is it going to impact my field. And there's very little, I think, stopping, except obviously bandwidth, and none of us have enough bandwidth. And I know I'm preaching to the choir here on bandwidth probably, but I think there's very little, there's a much lower barrier to entry than I think people anticipate when they start. And everyone can get started with, the laptop that they were on at some point today, or even the phone that they're maybe on right now. And I think that's a unique part about this. And, I often talk about as well that the last time we really had something, when we started understanding, classical computation in the 50s and 60s, we didn't have armies of computer scientists and open source software and cloud access to resources. Like we didn't have all of the things that we have today that couple with this technology that are going to accelerate it, but also make it a much more accessible place to start if you have the bandwidth and the desire. And I think there's a massive amount of opportunity from academia to think about obviously workforce development and education. It's a huge thing we all need to do, as well as if you're already sitting in industry and you're thinking about an evolution of your workforce. I don't see a future where there's like classical people and quantum people. There's going to be people that use technology to solve problems, and all of these technologies are going to come together to solve those problems.
And I think what you're saying is, as a community, we've advanced the technology enough to lower barriers to getting started.
Yes, absolutely. And I think that the technology readiness of this technology is, every day there's a new something that is putting it much more on that technology readiness scale. So
I think I want to switch gears a little bit. You mentioned our ecosystem, and I know IBM has had lots of successful partnerships in our ecosystem, from research partnerships with the University of Chicago and UIUC to my personal favorites in some ways, like from our first cohort of duality startups, you partnered with Supertech on they were helping IBM with pulse level control. You're partnering with QBraid, another duality cohort 1 startup, on providing access via their platform. Tell me a little bit about how these partnerships advance IBM's mission and how they advance the technology. And to you, what is a successful partnership?
Yeah.
What are you looking for from?
IBM definitely is not going to do this alone. I think a lot of the partners that you talked about, if we think about QBraid was something that we were kind of trying to do internally. We had kind of a platform. They did it better. We used their platform. It's been incredibly successful in a lot of different places. We partnered with Pascal. We had a chance to chat earlier as well, thinking about the middleware and how we build on top. We announced a lot of new functions, QCware, QControl. We're making a platform that we want others to build on top of to also derive their own value and push value. The main thing that we all want in this room, and IBM still, IBM is 100% behind, is just bringing quantum computing to practical and useful value. And when we know we can't do that on our own, we have to create a platform for other people to build with great ideas that are going to advance the platform and advance the technology. We need to have deep academic collaborations, as you talked about. We've got an incredible group of people. There are incredible groups of people all over the planet that we will learn from and be better together in our kind of deeper research collaborations.
And the most incredible ones are here in this
Obviously,
room.
Goes without saying. I will say though, and we've talked about this a lot over the past couple of days, this really is an incredibly unique ecosystem. Not only the way that the approach has happened, across the different organizations like CQE that's pulling all this together, but really pushing this academia, industry, government, really putting it together and trying to pull all those pieces together in like that positive tension that we were talking about, with the national labs in the backyard and all the incredible institutions, like it's a special place. And we see, you know, this is like a microcosm of some other ecosystems we see in other geos around the world, but this is really a special place. And so yes, we need partnerships across that stack, but we are definitely not, we are partnering so other people can derive their own individual value and create their own value on the platform, whether it's the middleware or error suppression mitigation techniques. We have chemistry functions, machine learning functions. There's many parts of the stack that IBM is definitely wants other people to come and derive their own value and build their own use cases out of it. I think our most successful partnerships are similar a little bit to what I was saying earlier, that they have that kind of long-term vision in mind, but there's so many shared goals that we can all have in the ecosystem now. And I think we are a big community, whether or not we're pursuing different software stacks or different modalities or different research objectives, like we all have the same common objective in mind. And I think that's a really beautiful part of where the technology is. You know, we can still be in a very collaborative, not fully competitive space right now. And I think we need to use it to its nth degree, because what's the saying? Like, all ships rise together. What is it? Somebody? It's like all...
The rising tide raises all boats.
You guys are listening. I like it. So yeah, I think that's an important part, is like having shared common goal, common mission, but really kind of baked in where we are. Kind of back to that scientific rigor met with accelerated demands.
It's a very heartwarming place to get to. And I think we are at the end of our time. Well, thanks, Katie.
Thank you.